Modern tools allow both humans and machines to think at unprecedented length and speed. Yet, real-world failures still come from decisions that seemed logically sound but were poorly tested. Elaborate reasoning can drift away from reality when it is not corrected by feedback, even as it becomes more sophisticated. This creates a paradox. Increasing intelligence does not reliably reduce errors. This video examines where reasoning reaches its limits and clarifies what this means for AI, human judgment, and the role of action, without claiming a complete or final answer. A perspective on AI is that eventually reasoning models will have all the answers, and all the value will be in the questions. This idea may, however, be flawed. While how we use AI and in part what questions we ask greatly affects AI's usefulness, the assumption that AI will have all the answers does not align with what we see in practice. From a technical standpoint, large language models learn patterns from training data that may include high-quality sources such as textbooks and academic material. This enables impressive generalization, but it does not equate to complete knowledge. Improvements in reasoning models reduce certain classes of errors, yet reasoning remains dependent on the underlying assumptions, priors, and incomplete information. Better reasoning does not automatically compensate for missing or incorrect data. A useful analogy is to think about an exceptionally intelligent person. Such a person may spend months planning the optimal path forward, carefully reasoning through every possible scenario, only to discover that the messiness of reality does not match what they expected. Markets shift, people react unpredictably, and constraints emerge that were invisible on paper. Planning is valuable, but when it is not tested against reality, it can drift further and further from the truth. Consider a simple example: becoming physically fit. One approach is to learn just enough to start exercising and then start working out. After working out, you might notice that certain joints hurt, and you can look up resources on taking care of your joints. After that, you can continue to alternate between applying theory and learning theory each time you encounter an issue. Alternatively, you could spend a year researching how to maximize muscle growth by lifting heavy and taking the right supplements. But on your first workout, you lift too much and immediately injure yourself. This pattern maps closely to how automated agents behave. Systems that operate in environments with feedback evaluation signals, retries, and external checks tend to outperform systems that rely on long chains of internal reasoning alone. Empirically, agents with access to ground truth signals or structured feedback loops make fewer compounding errors than agents that reason in isolation. The broader lesson is that whether one is human or machine, progress towards real-world goals is rarely achieved through reasoning alone. A willingness to try, fail, observe, and adjust increases the odds of success. This is not reckless experimentation, it is informed iteration. Planning sets direction, but feedback provides correction. Before we get ahead of ourselves, though, it is important to recognize that current models have limitations. It is important to realize that even if an answer could reasonably be deduced by the average human, an agent may still unexpectedly return a false answer. Even in tasks where agents perform well, accuracy cannot be expected to be 100%. In fact, for general knowledge tasks, typical error rates vary, but can be between 15 and 75% for LLMs without RAG, depending on the complexity of the domain and question type. While RAG helps by grounding responses in retrieved documents, it is only as accurate as the underlying retrieval quality and source reliability. If RAG is just doing an internet search, then we must remember that it is unwise to believe everything that is written online. Sometimes errors are blatantly factually wrong, but more often they are just not quite right, while still sounding correct. But what happens if we ignore the current constraints and just imagine some superintelligence that remembers all the facts we currently know and had perfect reasoning such that if a solution can be logically deducted, it will be? Even if we approach this outcome, reasoning alone is still not enough. There are several categories of limitations worth considering. Some knowledge cannot be deducted, it must be discovered. Firstly, some problems are observation problems. Scientific progress depends on experiments. Without interactions in the physical world, discoveries stagnate. Reading prior research helps, but it constrains insight to what already exists. AI could be connected to a robotic system to conduct its own experiments, but this introduces additional complexity. The system would still need equipment, materials, experimental design, and the ability to interpret physical results. These are engineering challenges distinct from reasoning capabilities. Secondly, some knowledge is not based on reasoning or physical experiments. Morality, for example, cannot be logically deducted in isolation. We can use logic to apply moral frameworks by drawing logical diagrams with premises and conclusions, but those initial core premises are things that we as humans chose to agree upon. A more capable AI may become better at applying moral reasoning consistently, but it cannot improve the core premises themselves. If it did, we might say that it had gone rogue. Preferences function similarly. They are not fully deductible and often vary between individuals. Tools, including AI, can assist in expressing or refining preferences, but they cannot replace human intent. Finally, many of the world's hardest problems are not intelligence limited, but resource limited. Diseases, policy decisions, and lifestyle challenges often involve resource limitations, not knowledge gaps. We do not need superintelligence for everyone to get a new car each year. What we would need are vast amounts of metal, factories, and labor that are simply not available. It is a classical economic problem. Unlimited wants with limited resources. AI could help optimize resource allocation, and that is genuinely exciting, but it will not create resources out of thin air. A perspective might be that the most valuable AI would actually tell us to cut back, focus on reducing waste, and using resources better rather than trying to help us consume more. For example, a safe, livable city with trains and bike lanes rather than bigger and bigger cars, perhaps along with working less, since fewer resources and less complexity is needed after cutting back on consumption. Consider a focus on living comfortably instead of working more to try to impress or outcompete others. Instead of a future where there are infinite goods, a more realistic future might be one where we balance needs thoughtfully. To apply these ideas, let's consider a consulting firm building an AI-driven financial analytics tool. On paper, the challenge looks technical: models, dashboards, and optimization algorithms. However, in practice, the biggest limitations may be that much of a client's knowledge is not written down. It lives in conversations, habits, and informal decision-making. A practical approach could be to treat data acquisition as a core differentiator. Human-led interviews, stakeholder workshops, and structured knowledge capture can surface latent information. That context can then be integrated into a system through retrieval pipelines or structured inputs. In the setup, AI handles synthesis and pattern recognition, while humans handle discovery and trust building. So, besides some AI engineering, the focus centers on data gathering, context building, and quality control. The AI handles the synthesis and initial draft, and the humans handle the parts that require judgment and relationships. So, where does this leave us? Not in a place of disappointment about AI's limitations, but rather in a more realistic and arguably more exciting space. AI is not a replacement for human insight, experimentation, or judgment. It is a powerful tool that works best when integrated thoughtfully into systems that account for what it can and cannot do. For those building applications, this suggests a particular approach. Design for iteration, build in mechanisms for feedback, and never assume that the model will get it right on the first trial. Treat AI outputs as drafts, as starting points that benefit from human refinement and real-world testing. This is not a limitation, it is the nature of problem solving, and working with that nature rather than against it leads to better results. Perhaps there is something reassuring in that. The value we provide as humans, our ability to gather context, to understand nuance, to learn from experience, to navigate resource constraints and moral questions, these capabilities remain essential even as AI assists us. The future might not be about AI doing everything while we simply prompt it. The future might be about building systems where AI and human intelligence complement each other.